Hi there, welcome to brilliantmaths.com, where every student has an opportunity to excel in math. Subscribe to brilliantmaths.com. You will be surprised how you will improve. Grab Module 3 because our next lesson is from there. Today we are looking at quadratic expressions and equations, factorizing by grouping. The first example is y squared plus 5y minus 3y minus 15. We want to factorize by grouping the terms. As you can see, this expression has 4 terms: y squared plus 5y minus 3y minus 15. So we can group together y squared and 5y, and then factorize the minus sign, since both of them have a minus sign in front of them, and also group together 3y and 15. But this time, the sign between them will be positive because we have factorized the minus sign. And then this becomes y into y plus 5 because y is common. We take out the common y. Y squared divided by y will give us y, plus 5y divided by y will leave us with 5 inside the bracket, minus what is common to 3y and 15 is 3. So 3y divided by 3 will leave us with y, plus 15 divided by 3 will give us 5. So now, as you can see, y plus 5 has become a common term to both. So we factorize that, and that gives us y plus 5. If we take out the y plus 5 from this term, we are left with y minus. If we also take out the y plus 5 from that term, we are left with 3. So if we factorize y squared plus 5y minus 3y minus 15, we would get y plus 5 into y minus 3. And if you expand these two brackets, you'll get the original expression. Always remember that factorization is the reverse of expansion. In the second example, we have 4b squared minus 6ab plus 18bc minus 27ac. We want to group them. So we would group 4b squared and 6ab, and then group 18bc and 27ac. So we have 4b squared minus 6ab in a group plus 18bc minus 27ac. Now we look out for the common terms. 2 is common to 4 and 6, so we factorize it. And also, b is common. So 2b is common to both of them. 4b squared divided by 2b will leave us with 2b, minus 6ab divided by 2b will leave us with 3a, plus 18bc and 27ac. What's common to them? 9 is common to 18 and 27, so we factorize 9. And also, c is common to both terms, so we also factorize c. So 9c is common. 18bc divided by 9c would leave us with 2b, minus 27ac divided by 9c would leave us with 3a. So here we see that 2b minus 3a has become common to both terms in this expression. So we have 2b minus 3a, we factorize it, and when we take it out, what would then be left? We'll be left with 2b on this side plus 9c. So if you factorize 4b squared minus 6ab plus 18bc minus 27ac, you would have 2b minus 3a into 2b plus 9c. And like I said earlier, if you expand this bracket, you should get the original expression. In this example, we are factorizing using difference of two squares. Example 1, x squared minus 16. X squared is a squared number, and 16 is also a squared number. Let's see how we do this. It becomes x squared minus 4 squared. So to factorize this, we open up two brackets. One bracket is x minus 4, and the other bracket is x plus 4. Let's expand this to see if it's correct, because that's our answer. X minus 4 into x plus 4. X times x is x squared. X times plus 4 is plus 4x. Minus 4 times x is minus 4x. Minus 4 times plus 4 is minus 16. Plus 4 minus 4 is 0. So we have x squared minus 16, which is the original expression. So difference of two squares. When you have squared numbers or squared factors, you simply find their square root, put them in squares, and then one bracket has a minus sign and the other bracket has a positive sign. In the next example, we have 9x squared minus 16y squared. 9 is also a squared number. So 3 squared x squared minus 4 squared y squared. So they are all squares now. So we can write it as a difference of two squares. We pick the 3 and the x minus 4y in one bracket. In the second bracket, 3x plus 4y. It's as simple as that. So let's check. 3x times 3x is 9x squared. 3x times 4y is 12xy, but that's positive because the 3x is positive and the 4y is positive. Minus 4y times 3x is minus 12xy. And minus 4y times plus 4y is minus 16y squared. Minus 12xy and plus 12xy goes to 0. So we have 9x squared minus 16y squared, which is the original expression. In this next example, you might not immediately see that there are a difference of two squares. Let's factorize and see. 8x squared minus 98y to the power 4. 8 is an even number, and 98 is an even number. So 2 is a common factor. 2 into 4x squared minus half of 98 is 49. So we have 49y to the power 4. 4 is a squared number, and 49 is a squared number. X squared y 4. So let's continue. It becomes 2 into 2 squared x squared minus 49 is 7 squared, and y to the power 4 is y squared squared. This looks very interesting. So the difference of two squares here would be 2 into 2 2x squared into 2x minus 7y squared into 2x plus 7y squared. Let's expand this quickly to cross-check. 2x times 2x, we still leave the 2 outside. 2x times 2x, that's our check, is 4x squared. 2x times 7y squared is 14xy squared. Again, minus 7y squared times 2x will give us minus 14xy squared, so that both of them will cancel out. Minus 7y squared times plus 7y squared will then give us minus 49y to the power 4. And then, by the time we multiply through by the 2, remember these 2 are gone, minus and plus, so it becomes 0. 2 times 4 will then give us 8x squared minus 49 times 2 will give us 98. And then we have y to the power 4, which is our original expression. So just take your time anytime you have to use to factorize difference of two squares. Just take your time and look out for the squared numbers and a possible common factor. You can factorize difference. A difference of two squares have factors, but the sum of two squares cannot be factorized. Next, we want to learn how to factorize quadratic expressions, general quadratic expressions. For example, factorize x squared plus 7x plus 12. What we need to do here is find the factors of the constant term, which is 12, such that when you multiply the factors, it will give you 12. But when you add them, it will give you the coefficient of the middle term, which is 7. So we want factors of 12. So possible factors of 12 are 1 times 12 is equal to 12. We're looking for possible factors of positive 12. Okay? 3 times 4 is 12, both positive. And 3 plus 4 will give us 7. So those factors are 3 and 4. So we split up the middle term into a sum of the two factors. Solution: x squared plus 7x plus 12 is equal to x squared plus 3x plus 4x plus 12. We haven't made any major changes. We have just split 7x into 3x plus 4x, because 3x plus 4x will give us 7x, and 3 times 4 will give us 12. So this becomes, we now group, as we have learned, x squared plus 3x. We group it together, plus 4x plus 12. Then, find the common factors in each group. This is equal to, x is common, so x into x plus 3 plus, and then 4 is common to 4x and 12. 4 into x, 4 into 12 is 3 plus 3. So x plus 3 is now common. So we have x plus 3. If you take out x plus 3, or divide that by x plus 3, we are left with x. And since that has been factorized, we are left with 4. So if we factorize x squared plus 7x plus 12, we would have x plus 3 into x plus 4. If you expand this, you would get the original expression. In this next example, we want to factorize minus 11x plus 7x squared minus 6. So the first thing will be to rearrange this expression into the general form of quadratic expressions, which is ax squared plus bx plus c, where a is the coefficient of the quadratic term, b is the coefficient of the linear term, and c is a constant. So solution, I write the question again, minus 11x plus 7x squared minus 6. And then I rearrange into that form. So I have 7x squared minus 11x minus 6. In this example, the coefficient of the quadratic term is not 1, it's 7. So we'll find the product of the coefficient of the quadratic term and the constant. So we're multiplying 7 times minus 6, which is equal to minus 42. We want factors of minus 42 such that the sum will be 11. We need to find factors of minus 42 such that when you multiply the two numbers, it will give you minus 42. But when you add them, it will give you minus 11. 7 times minus 6 is minus 42. But 7 minus 6 will not give 11. So the factors are not 6 and 7. We're now looking for factors of 42. Minus 42. Let's try 21 times 2. Minus 21 times 2 will give minus 42. That's product. But minus 21 plus 2 is not equal to minus 11. That will give minus 19. So we can't use those. Divided by 3 is 14. So we'll try minus 14 times 3. I'm trying the minus 14 because the middle term is negative. So I'm using minus 14 instead of minus 3 because I want to get a negative middle term. So minus 14 times 3. 3 times 4 is 12. Carry 1. 3 times 1 is 3 plus 1, 4. So that's minus 42. So the product is correct. And then let's see the sum. Minus 14 plus 3 would give us minus 11, which is the sum we are looking for. So the factors will be minus 14 and plus 3. So we simply replace the middle term here with minus 14x plus 3x. So it becomes 7x squared minus 14x plus 3x minus 6. Then we group 7x squared minus 14x in one group plus 3x minus 6. We factorize. What is common? 7x is common in this group. So if we take out 7x, we are left with x minus 2. And also, in this bracket, 3 is common. If we take out 3, we'll be left with x minus 2. Then we find that x minus 2 is common to both terms now. We factorize it, x minus 2, and then we are left with 7x plus 3 in the second bracket. So when you factorize minus 11x plus 7x squared minus 6, you'd get x minus 2 in one bracket into 7x plus 3 in the second bracket. This is how to factorize quadratic expressions when the coefficient of the quadratic term It's not 1. But you can also use it to factorize quadratic terms where the quadratic term is also 1. So it works, this method works for any kind of factorization of quadratic expressions. Here we want to factorize algebraic fractions. In the first example, says simplify x squared minus 3x over x squared plus 3x. So, solution. We find the common factors between x squared and 3x. And x is a common factor. So we factorize it. So we have x squared minus 3x over x squared plus 3x. So x is common to both terms of the numerator. So we factorize it, x into x minus 3. And also, x is common to both terms of the denominator. So we factorize it, and we have x into x plus 3. We can then cancel out the x, and our answer becomes x minus 3 into x plus 3. And that's the final answer. In example 2, simplify x squared minus 2x over x squared plus x minus 6. We need to factorize x squared plus x minus 6 the way we have learned how to factorize quadratic expressions, and then also factorize x squared minus 2x by taking x out because it's common to x squared and minus 2. So let's see what we have. So x squared minus 2x over x squared plus x minus 6. So here we have x common, so we take it out, x minus 2. And then in the denominator, we look for factors of minus 6 such that when you multiply those factors, it will give you minus 6. And when you add them, it will give you 1. Because the coefficient of x here is 1. And those two factors are minus 2 and plus 3. So I'll simply replace the x with plus 3x minus 2x. So I have x squared plus 3x minus 2x minus 6. Still carrying on with my factorization, I will then have x squared plus 3x in one bracket and have 2x plus 2x plus 6 in another bracket. It becomes x into x minus 2 over x squared plus 3x minus 2x plus 6. I continue my factorization. So I have the numerator as x into x minus 2. And then my denominator becomes x into x plus 3 minus 2 into x plus 3. So that my final answer is going to be x into x minus 2 over x plus 3 into x minus 2. Let's see how it plays out here. X into x minus 2 over x plus 3 into x minus 2. And this cancels out, leaving us with x over x plus 3 as a final answer. Next, we want to multiply algebraic fractions. And the rules for multiplying fractions will apply here. So we're going to go through it very quickly. Example 1. Simplify x over 3 times x plus 2 over x minus 2. There are no common factors, so we will simply multiply the numerator of the first term by the numerator of the second term, and the denominator of the first term by the denominator of the second term. So let's go. Solution. X over 3 times x plus 2 over x minus 2 becomes x into x plus 2, x into x plus 2. Because we are simply multiplying x by x plus 2 over 3 into x minus 2. And our final answer will become x squared plus 2 over 3x minus 6. That is 3 times x minus 3 times 2. Simple. In the next example, we have 2y over 5 divided by y over 3. We know how to divide. When you change your division sign to multiplication, then you reciprocate the term after the division sign. So we have, let's take our solution. It becomes 2y over 5 divided by y over 3. I usually like to write the question again. So this is now 2y over 5 times 3 over y. Then here we can cancel out. Y can cancel out the y on top. And then 2 times 3 is equal to 6 over 5. So our final answer is 6 over 5, or 1/5. That is very simple. So when you have to multiply or divide algebraic fractions, follow the rules for working with fractions. In this example, we want to add and subtract algebraic fractions. And the rules for adding and subtracting fractions still holds. So let's quickly do these ones. Example 1, 2 over 5x plus 3 over 10x. So let's take the solution. The first step will be to find the LCM of 5x and 10x, which is 10x. So LCM of the denominators of 5x and 10x is equal to 10x. So I want to put both of them under the same denominator of 10x. So 5x into 10x, or 10x divided by 5x, we have 2. Because 2 times 5x will give us 10x. So we have 2 times 2 plus 10x into 10x is 1. 1 times 3 is 3. So this becomes 4 plus 3 over 10x. And the final answer is 7 over 10x. Simple. In the next one, we have 5 over x plus 3 minus 3 over x minus 5. So what is the LCM of the two denominators? It will be the product of the two denominators. So let's take our solution. LCM of x plus 3 and x minus 5 is the product of both x plus 3 into x minus 5. So next, I want to put the two terms under the same denominator, which is the LCM. The common denominator, x plus 3 into x minus 5. When I divide that by the first denominator, the x plus 3 will cancel out, and what I have left will be 5 times x minus 5. So 5 into x minus 5. My minus sign is there. When I divide the denominator by the second, when I divide the LCM by the second denominator, the x minus 5 will cancel out, and what I have left will be x plus 3. So it will be 3 into x plus 3. So next, I'm going to expand this to have 5x minus 25, 5x minus 25, minus 3x minus 3x minus 9 all over x plus 3 into x minus 5. Next, I collect the like terms. 5x minus 3x will be 2x. That's 2x. Minus 25 minus 9 will be minus 34 over x plus 3 into x minus 5. So that's my final answer. You need to be very careful when you are working with algebraic fractions. More complicated ones like this just need practice and time. For more of this, subscribe to brilliantmaths.com Module 3. You'll find lots and lots of exercises. Go to the Brilliant Maths website. You have lots of resources there to help you excel in math. I am Ngozi Orevogene, and always remember that maths is fun and you can do it.